Oh ya, itu siapa Pak Harida ya? Oke.
Oke, sorry started.
Oke, thank you Pak Harida.
Oke, selamat siang Bapak Ibu. Good day and good afternoon for Prof. Andrew. Today we will have, I think the fifth or fourth discussion of the fourth discussion for us as teacher to teach structure. And today we will have our agenda. The first we will discuss and we will I think heard the presentation from the research group. It's Pak Arshad and Pak Harida will present their research proposal, and then the second agenda is we will review the students' work. It's the studio design of Win Malang. We call it Dai 3. And for me today, I would like to help the discussion maybe in terms of translating and to help moderate the discussion. But please interrupt anytime if you have suggestion or question. And everyone could use bahasa or English. Silahkan bisa menggunakan bahasa Indonesia. Nanti saya akan membantu sedikit mentranslate, ataupun dalam bahasa Inggris juga tidak apa-apa. Pak Andrew could also understand bahasa. So that's the welcome for me.
Saja.
Yes. Nah, it's a lot. Well, selamat datang Bapak Ibu semua. Sekali lagi saya perkenalkan, saya Suci Senjana yang akan membantu pada hari ini. Untuk pertama, saya mungkin I would like to let Pak Arsyad to present the presentation, please.
Okay, thank you, Bu Suci. Assalamualaikum warahmatullahi wabarakatuh, and very good afternoon. Hello, Prof. Andrew Charleson.
Hello.
Nice to meet you. Okay, I will start share screen. Okay, anybody can see this?
Yes.
Yes, clear.
Okay. Thank you for time and place for us to present this research project. My team is me, Muhammad Arshad Bahar, and Mr. Aldin Yusuf Rimansa and Mr. Harida Samudro. We have an idea to create some framework. We call it an innovative and interactive framework, learning building technology for Islamic architecture design, DAI Studio Architecture Department, UIN Malang. So this idea is come from the latest our discussion. Okay. Latest discussion. We have created new framework, new mind map from the building technology course subjects, but we don't have any evaluate before, especially for in pandemic learning in online course. So this project is to evaluate and review how the successfully for the mind map. Thank you for Andrew that have correct and review our paper that have we sent to you before. But today we not discuss about that more deeply, because I think the participant is more general. So we discuss about more general, and I think it's very good for our department. Maybe next time we can discuss about our paper review proposal later day. Okay. So this is the general background why we chose this idea to create a new framework from the building technology course. The first is curriculum of architecture education work that required the aspect of building technology, aesthetic, culture, function, and comprehensive lecturer. So this is the first general background. And the second is construction industry. We know we have come into the industrial revolution 4.0, yeah, that must we adapt into the learning, especially for the BIM, building information modeling, and then the pedagogy of technical fields. We must teaching with the problem-based learning (PBL) and sustainable interactive independent learning. And Department Architecture UIN Malang is focused to pre-develop curriculum with DAI and building technology 1 until 4 course. So okay. Okay, the next general background is learning experience technical field. We know we are the technical engineer, so we must learn or make the student learning everything with the experience. So this is the general background why we choose an innovative and interactive framework, because this is a very important thing if we want to teaching the building technology course in the online lecturing, online course. And this is the specific background why we chose that idea, because we must create some strategy of distance learning. For distance learning, pandemic COVID-19, we must teaching and learning with far distance and online method. So this is very important if we can create strategy online learning from building technology, not DA, the design Islamic architecture studio only, but also the structure in building technology also. So this is the main goals. Our research goal, the first is evaluating mind map building technology. We have built some mind map for building technology, but we not yet evaluate, especially for the online course 1 years before. And this research is to evaluate and to review. Yeah. And then the second goal is creating learning strategy for the building technology, how to determine strategy to focus interactive and innovative learning method. So are the teacher learning center or student learning center. So this is, we want to find and create some strategy. So the main goal is we try to keep to create innovative and interactive building technology learning framework, especially for building technology subjects. Okay, before that, we must know about the correlation between building technology course and the AI studio in our department. This is course integration, the latest version, recontext we call it, but still in Indonesian. This is the correlation between course subject one to another's. And then this is our focus, integration of building technology with design studio. So Studio 1 is supported by basic construction, and building technology 1 is to support Studio 1 also, but they focus more focused to Studio 2, the AI 2, we call it. And then building technology 2 supporting Studio 3 and building Technology 3 to support Studio 4, and Building Technology 4 to support Studio 5. So this is the correlation between Building Technology subject with Studio. This is mind map for Building Technology that we have created before. Let us semester, but we not evaluate yet how this is the correct or how or different or not with the studio design. So this project research is to find them, to identify are they good or how. So this is the keyword. Teknologi bangunan 1 or building technology 1 is knowing, focus keyword. Building technology to ringing, the building technology 2 to reading, and building technology 4 to understanding. So this is the the mind map of our building technology. Before this, DI Studio already done also create the mind map and lecturing methods for the studio. So now it's time to create the same thing at the same time, the same things for the building technology. This is the our research concern. So this is the goal 1 is, did the building technology mind map already applied during the lecturer in online learning for this year? So you want to know, are the mind map is already done, already applied with relevance with the mind map on in the class, online class. The goal 1, and we know in the learning method before in our learning we have some method. The first is offline, have been disbanded since the pandemic. Yeah, it's not allowed all the lockdown, and we must online learning. We can choose the different method like live streaming, video tutorial, live chat, and e-learning. So this is the some building technology learning methods. And then this is goal 2. Did the building technology learning method before, like this of live streaming, video tutorial, live chat, e-learning, this is run well or not according the mind map, interactive and innovative. Interactive mean not only the teacher learning centered, but also student centered learning. Yeah. Interactive, so student and teacher together create the interactive class. And then innovative means interesting and creative learning, so more happiness learning for the building technology or structure. So our methodology for this project research is we are using the inductive analysis. We start from the review of contents, mind map buildings, technology, and design studio. And then we doing some questionnaire from Google Form about building technology 1 until 4 students during online course, maybe 1 year before. And then data analysis using the problem-based learning PBL by Barros and virtual learning environment VLE by Sakon. And then that's data we discussion and analysis and try to create innovative and interactive building technology learning framework for building technology course. So this is the inductive analysis. We divide into 2 steps. The step 1 is evaluate aspect from the mind map and the AI studio based on PBL and VLE. And then step 2, we develop the concept, new concept, also from the PBL and VLE. And then we try to create new learning framework from building technology. And then we find some strategy to mind map review. we have four steps. The first is we examining the existing building technology mind map, the latest curriculum, the context, and then the second step is we reviewing the semester learning plan or rencana pembelajaran semester RPS we call it. Are they relevant with the mind map or not? And then the third is implementation evaluation. We observation live to the student building technology 1 until 4. And then the last is review mind map and try to create new mind map for building technology that's more relevant in the hybrid system learning or in the online learning. This is the goal ones, hypothesis, and then the second goals is like this student-centered framework. So we can create interactive learning with the student-centered framework. This is the reference to this journal, an innovative framework of technical learning. We have four method. The first is student class presentation, and the second is class drawing activities and site visit, and the third is problem-based learning, and the fourth is self-reflecting report and learning diaries. So this is the way to we create the interactive class learning. Yeah. So the last is we create T-box, we call it, to build online exhibition. So product of building technology course we can exhibit in the website. We call it T-box, the build online exhibitions. Like Studio DAI, they have also DOX, DAI online exhibition. So technology bangunan or building technology also have the some innovative or creative presentation. We call it T-box, the building online exhibition in Google. Okay, so I think that's our project research, Prof. Andrew. Why we create this idea, because we now nowadays in the pandemic era, so we can create. We want to create a good learning methods for the online learning. Okay, maybe this is enough. I will hopefully like Prof. Andrew to give us a comment or some correction or some methods that more helpful to do this our project. Thank you.
Thank you, Pak Arshad, for the presentation. Maybe Pak Andrew would like to give the response, please.
Yeah, sure. Thank you very much for your presentation. I think your aim is a very good aim to bring the teaching of technologies into, you know, the modern time, and make it right up to date with the other media that the students are getting used to, like virtual reality and so on. I've probably got several comments. One comment is that you're going to do some evaluation of the students' experiences using this new approach. And I think that's really important. But I also think you should try and evaluate whether this new approach is more effective at educating the students. And this is a lot more difficult to do, of course. I mean, it's easy to evaluate student attitudes and student opinion. That's really easy. But I think what you also need to do is to try and demonstrate that the new technologies have a better outcome in terms of the knowledge and the skills of the students. And as I say, that's a lot more difficult. And I'm not sure exactly how you might do that, but other academics will have done so. And, you know, you'll be able to look at literature to get guidance on that. So that's one comment I've got.
Yes.
Do you want to respond, or shall I just keep on speaking for a few minutes?
Okay. We using the students for fill the Google form, and then the parameter is from the problem-based learning (PBL) borrows and virtual learning environment, and we using the parameter link like or that our the answer we orange before, so the student just only yes or no, like or not, like that. So we can control the parameter like that.
That's right. Well, that's fine, and that's important to do that. But as I said, you also need to check that the student's knowledge is improved using these new technologies, this new approach.
Yes.
So you need to have some baseline of student knowledge and skill, and then you need to try and determine if your new approach is actually making your students, you know, better architects, better able to master the architectural technologies. So yeah, that was one thing I think that might be helpful. Are the students using virtual reality at the moment? Or is this something for the future? I'll just ask that question again. Are your students already using some virtual reality in their technology studies?
Reality. Excuse me. Yeah. Virtual reality.
Okay, well, let me make another comment, and that is what I don't quite understand is the degree to which the building technology will be integrated in the design studio work. And how will that technology be assessed? And so these are quite tricky issues, because it means that you do need a very high level of integration between your design studio and your technology content to provide a method where the students are really, they're forced to integrate the technologies, you know, with their design studio work. And so that's quite challenging, because, you know, you need good tutors and you need to have good assessment so the students can be rewarded, you know, for integrating the technologies well in their projects. So those are just some other thoughts for you to consider.
Thank you, Pak Andrew. And Pak Arshad and Pak Rida, is there any further questions maybe for Pak Andrew before we move on?
Okay, maybe I have a question.
Yes,
There is
please.
here. Yeah. Excuse me, Prof. Andrew. I want to ask about problem-based learning that mentioned before in the presentation. That we believe that by working in this ill-defined problem, students could study other topics related to the potential consequence on various building parts to identify the risks and then create solutions. Students may acquire knowledge of materials, structures, construction techniques, and other factors in order to develop a plans. How can you make the same suggestions about from problem-based learning? Thank you.
Yeah, I mean, it's a really good question, Pakarida.
Yeah.
I think that problem-based learning definitely has some strengths, but it also has some weaknesses because every student, because there's certain knowledge that every student must have. Like, for example, every student must have a basic understanding of designing a building against earthquakes. And so you must make sure, and likewise, like every student must have a basic knowledge of the principles for designing cladding.
Okay.
And so on one hand, you do want the students to learn through the problems that you give them. But on the other hand, they do need some basic skills and knowledge.
Oh, okay. Yes.
Because otherwise they could go through their architectural career without a sound knowledge, for example, of the need for insulation in certain areas of the building, or a sound knowledge of what the conditions of the foundations have to be.
Yeah.
So my recommendation would be to have a mixture of giving the students sort of basic principles, and then as well as that, give them problem-based learning activities.
Yes, of course.
So does that make sense?
Yes, of course. Yes, really makes sense. So the students, before we provide the problem base, we need to give them to some basic principles to structures, right?
Yeah, I believe so.
Okay.
Because as we know, there is so much information on the internet, but we are in the position of giving guidance as to what is really important.
Okay.
Which, you know, what are the basic principles they must understand? And so we have to like be the curators. We have to be the interpreters of that knowledge that they can then base all their new problem-based learning knowledge on. We need to give them like the framework, the principles and the framework, and then they can add all the knowledge they get from their problem solving.
Yes, of course. Okay, one more question, maybe, if there is time. So, we believe that in this pandemic situations, we push to teaching in the online. So to develop their skills, to develop their knowledge, we try to give them some self-reflecting reports and learning diaries. Learning diaries were required from the students as a self-assessment tool from the beginning to the end of semester. I believe that the learning diary reports were was very substantial to give reports of study for the students. Um, uh, how do you think about uh, progress reports in tasks of the maybe ask on the students to give reports for teacher?
Could you please repeat the last sentence?
Okay, how do you think about the apa tadi? Lupa.
Apa Pak? Bahasa Indonesianya
I'm
apa Pak?
sorry. Ya, tadi tolong bahasa Inggris kan Bu Suci ya.
Ya.
Bagaimana menurut Prof Andrew tentang report ya, report dari keseluruhan tugas yang baik untuk diberikan kepada dosennya.
Right. But Andrew, would you have a suggestion? What kind, or what type of is it a journal, like journal or report from the student? Is it like a certain format that should be given from the students to the teacher? I think is it a report, Pak Arida? Do you mean
Yes.
report?
Okay. Thank you.
Well, I think it has got value to get the students to do self-reflection, but remember that students are not in a very good position to reflect because of their limited knowledge. And so I think to give a few marks for self-reflection is good, but basically the students have to have their work assessed by us knowledgeable people as well. Like, I mean, I don't think it's very helpful for a student to get a lot of marks for self-reflecting on their design or what they've learned, because they haven't got the knowledge. They're not critical enough.
Mm-hmm.
Because by nature, students are needing to mature, and they need us to provide the guidance and the criteria of what's acceptable. Like, I mean, they don't really know what is acceptable or not, but we know because of our experience. So I think there is some value in what you're suggesting, but I wouldn't push it too hard.
Okay. Okay.
Okay, is there, I think all the question has been asked, Pak Arida and Pak Arsyad.
Prof Andrew.
Oh yeah.
What for your suggestion, Prof? How we teach structure in pandemic like this or in online learning? How to teach structure with the distance online system like this?
Well, I think you have to be very creative. And I think you need to try and use as many different media as possible.
Yes.
So I think you should give some lectures.
Yeah.
And then I think you should get the students to go and observe some buildings that have been completed and do sketching and you know, some field work that they can do close to their homes. Maybe they can just observe a building under construction without going onto the site. And, you know, they can do sketches and explain the structural principles. And so, and then you could get them to do some research. They could choose a building that they like online, and they could write a little report about how the gravity loads are resisted and how the building resists earthquake forces. So yeah, I think you can keep on doing lectures, but you need to get the students to engage with buildings in their own environment that they can learn from, you know, and write little reports for you that you can mark and give them feedback on.
Oh, yeah. So using that's their environment to basic learning from problem-based learning like that.
Yeah, I mean, you should get them. You should force them to go and to go to a building, like make them go to the nearest library building, at town or village or their city, or a swimming pool, and you know, sketch the structure, do a little report, and because you've got to get your students away from the computer.
Yeah, yes.
And so you can get them to do some field studies like that. Okay. I think that would make it, you know, really interesting for them as well.
So how we can create the interactive class from the online learning like this? Interactive for student learning center like that. So student can creative, can present or how what?
Yes, look, I'm afraid I haven't had any experience of that. So look, I'm not really able to help you with that. But I mean, I think you've already probably tried some software that helps you get some discussion going. But it's a challenge, isn't it? It is a real challenge.
Yes.
Very difficult.
Very difficult. Yes, true.
Yeah.
Yes, this is our problematic because we are learning substructure or design in the online learning method. So this is our challenges. Okay, thank you, Prof.
But could I just add one other thing? I mean, say you're doing a lecture on structural frames of beams and columns. Well, you could ask the students to make some little models. And the students could they could make a little model out of wood or plastic or something, and you could get them to apply forces, you know, to the structure, and do a little demonstration, you know, in front of the rest of the class.
Yes, yes, great.
So sorry, I haven't got any amazing ideas for you.
Yes, because the pandemic is just it's just come to me. Okay, thank you, bro.
It's fine.
Okay, I think that was the discussion about the research proposal from Pak Arsyad and Pak Rida. Thank you. And maybe Prof. Andrew would like to move on to another topic that you would like to share.
Yeah, sure. Could I please, am I able to share a screen with you?
Yes, please.
Can you see
Yes,
my screen?
yes.
Okay. So what I'm going to do now is to review a student project. This is from the 3rd semester, I think. So what we decided was that we would look at 1 or 2 student projects from a structural perspective and just discuss, you know, how adequate these projects are. And so Ibu Yulia has sent me 4 projects, but I think we'll probably only have time for 1 or 1.5. Just depends how we go. And so first of all, I just want to say that the amount of work that the students have done in these projects, I find is absolutely amazing. You know, they've produced so many drawings and they've done a schedule of quantities and worked out the costs. And I personally feel that the students are being asked to do too much. But that's just my personal opinion. So they've done a huge amount of work and the students are to be congratulated, you know, for the work they do. So let's look at this house. It's a 2-story house. And as I say, we're going to look at it from the structural perspective. And so let's begin by looking at lantai satu, or the ground floor. Now, when it comes to looking or reviewing the structure of a building, I personally suggest to do it in like 2 steps. First of all, look at the gravity loads on the building and just see if the structure is adequate for gravity loads. And then we move on to the horizontal forces on the building, mainly from earthquake. And so that's the approach I'm going to take with this building. So first of all, we're asking ourselves the question, you know, what is the vertical structural system of this house that's been designed? And as we can see, the student has shown columns sort of distributed throughout the building. And so clearly the columns are part of the vertical system. However, the question really is the vertical structural system, is it a post and beam system or like a moment frame system, or are the walls load bearing? Could this be a system using confined masonry where we are not assuming frame action, but we're assuming load-bearing walls that are confined with tie columns and tie beams. Or are we having a combination of those two systems? And that is possible. And so the students really need to know what system they're using. Are they using a confined masonry structural system where the walls are load-bearing, or are they using a frame and infill system where the infills are intended to be non-structural? So that is a question that students have to think about, really. So let's go to, when we talk about gravity loads, let's sort of try and work down the building from the roof down to the foundations. And so we'll start by having a look at the roof. And you can see that in some parts of the roof, we've got, this is a section A. We've got trusses. This truss here is spanning between these two walls. And then elsewhere, we've got structural members also running to support the roof. And if we go to section B, here are those trusses, 3 trusses. And then here are beams supporting rafters that support the tiled roof. Now, notice that these beams are shown in cross section. And so this is section B. So if we go to Lante Dua, section B is here. And so what the student has designed beams spanning this way. In other words, spanning about 5 meters. Now, that is not sensible. It isn't sensible to span the longer distance. It would be more sensible to make the beams or the rafters span this way. Okay? And so the idea would be to have the rafters spanning this way, and then you put your battens for your tiles in this direction. And so the student hasn't designed a sensible structure for the roof. Okay, it's not sensible because these beams have to span 5 meters and they would have to be quite deep. Like for a timber beam to span 5 meters, it would have to be 30 to 40 centimeters deep. And the student has shown these beams being about 10 centimeters deep, maybe. I don't know. So you can see that we've got a problem with the roof structure because the student hasn't understood the principle of spanning the shorter span when you have a choice. Let me pause and see if any of you would like to ask a question about the roof structure.
Not yet, Prof.
Are there no questions?
No, not yet.
Okay, well, let me continue. I mean, I personally think like this is about a 4-meter span here. So a rafter spanning 4 meters has to be about 30 centimeters deep. That's quite a big rafter, isn't it? And so it might have been better for the student to design a truss here. Because then the bottom chords of the truss could support the ceiling. Now see, at the moment, this ceiling is spanning 5 meters and the ceiling joists are only 10 centimeters to span 5 meters. Well, that's impossible. They need to be about 40 centimeters or say 30 centimeters to span 5 meters to support the ceiling. And so I think a really good solution would have been to have trusses here to support the gravity loads from the weight of the roofing, the tiles, you know, and the supporting structure. So that's all I want to say about the roof structure. And so then the loads, you know, go down the walls or maybe columns. And so now let's begin to talk about lantai dua, this floor here. And first of all, we notice that here we've got a very high wall and there's no beam supporting it. So, you know, there must be quite a big beam here to support this wall. So we'll go to, and then the question is, you know, how thick is the slab? What is the depth of the slab here? Well, that depends on the
15 centimeters, I think, based on the width of the wall.
Oh, okay. Yeah, thank you. So the students use 15 centimeters. Okay. So let's go to the floor plan. Well, we need to go to the ground floor plan. And so the floor slab, you know, it has to span, well, we'll say the floor slab is spanning this way. It has to span about, well, it's more than 5 meters. So a floor slab spanning 5 meters, how thick, how deep does it need to be? It needs to be about 25 centimeters, doesn't it? here the floor slab can span between these two walls, and the span is about 4 meters. And so for a 4 meter span, the slab needs to be about 20 centimeters. So I don't think the student has thought very carefully about how deep the slab must be for the spans that it is required to span. Now, the other thing about the second floor, Lante Dua, is that we've got like penetrations in the floor. See, we've got stairs coming up here. And if we look at the plan, see, here is the penetration in the slab. And so the student should be providing a beam through here to support the edges of the slab. Now, if we look at, so if we look at the beam layout, sorry, we haven't got a beam layout. Oh, I haven't got one here. But essentially, the student hasn't shown the beams required to support the edges of some slabs where there are penetrations. And so the student needs to show beams under walls, and also show the elevation of beams under the slab. Also, we would need a beam here to support this weight of wall. And the little beam here, I don't think would be strong enough to span the distance. So there's some ways in which the student should be able to improve the structure for Lante Dua. Now, I just want to show you too, if we go back to I just want to show you where section A is taken. See, here is section A, and section A should show the stairs rising up to Lante Dua. But if we go to section A, you'll see the student hasn't drawn any stairs. And so, you know, the section is wrong. And I think this is something I'm a bit worried about, because you are asking the student to do so much work that it's really difficult for the student to, you know, do a good careful job, because the student is expected to do so much. And so here's an example, you know, where this section is wrong because it doesn't show the stairs going up to the second floor. It doesn't show the opening in the floor. And actually, there are other stairs here, I think it should show, but it doesn't. So let me just look at the beams, I need to go to slide 7. Oh no, well, I'm sorry, I can't do anything there. So I think those are my main points for the volante dua, which is the suspended slab. Basically, we need a lot more beams, and the slab has to be thicker unless the student provides secondary beams, in which case we have more beams, but we keep the slab, thinner. So it is possible to have the slab at 15 centimeters deep, but the student would have to provide additional secondary beams to support that slab. And those beams have to be shown in section and on the plan of the beams. Now let's have a look at the foundations. According to the foundation plan, we have some footings underneath certain columns. And we also have the stone continuous footings on the main grid lines. And so if we look at a section, here we've got loads coming down this wall here, here and here. And here is the continuous stone footing, which is traditional design, isn't it, in Indonesia? But then the student has shown this, this square footing underneath. Now that is really a very silly suggestion. We would never do that, ever. We would choose to either have our foundations in reinforced concrete like that, or have our foundations as a stone construction like this. We would never mix these two types of construction. And so, the student has used a system that really is rather silly. But, it's because of their lack of experience, I suppose. So the force paths, would be from down a wall, maybe through a beam, which is not shown, and down walls like this. And so that's really my discussion about the gravity systems of this building. I'll just put the slide to the ground floor, lantai satu, and I'll pause and see if anybody wants to ask any questions about the gravity resisting systems. All right, well, if there are no questions, I'm going to continue to talk about the earthquake resistance of this house. And so, first of all, let's look at earthquake attack in the Y direction, in the longitudinal direction. What is going to resist earthquakes in the longitudinal direction? Well, the good news is that there are two very strong walls in the y direction on grid 1 and grid 7. Both of these walls have no penetrations. They're solid masonry walls. And so if these walls were designed as confined masonry walls, they would be very effective to resist even a really large earthquake in the y direction. If we were using confined masonry construction, these columns don't need to be rectangular. They just need to be like column practice, practical columns, as part of confined masonry construction. There's no point in having rectangular columns, really, because confined masonry will resist the earthquake forces by forming diagonal compression struts within the masonry. So in the y direction, this house is very strong for earthquake. And I could also mention to you that there are also some shorter walls on grids 2 and 6 here, because these two walls, if we look at Lante Dua, you see the wall continues to the roof on grid 2, and also on grid 6, this wall continues to the roof. And so those two shorter walls, they can also help resist earthquake in the y direction. But actually, I don't think we need them because the walls on grids 1 and 7, on grids 1 and 6, they are so strong. Let me go back to Lante Satu. Oh, yeah, the student, I think, has made a mistake. It should be 6, grid line 6. Anyway, because that's the perimeter wall, and it's called number 7 on Lante 1, but on Lante Dua, it's called 6. So there's just a small mistake by the student there. So once again, if you have a wall that is continuous from the foundations to the roof, then that wall can help resist earthquakes. And so just to summarize, in the y direction, we have a wall on grid 1, which will be very strong because that wall is about 10 meters long. We have this shorter wall that is 2 stories high. It's only 3 meters long, but it will help a little. And then we have this wall here on, say, grid 5, which is 4 meters long. And finally, we have this very long wall here on grid 6. So very strong in the y direction. So that's good news. Now we come to the x direction for shaking across the building like this. So we ask ourselves, we start with lantai satu, and we ask ourselves, have we got any seismic resistance in this direction on grid A? And the answer is no, we haven't, because of all these windows in this wall. And we haven't even got a frame in this direction, because like that column is strong in the X direction, but this column is weak. It is weak in the X direction. So we don't really have any seismic resistance in the A grid line. What about B, the B grid line? Well, this wall is not strong because of all the penetrations. There's a little bit of wall here, but it's so short, it would be very weak. And so this column has no strength in this direction. This column has a little bit of strength, but this column has no bending strength because it's like a practical column. So really, on grid line B, there is no resistance. What about grid line C? Well, we have a very short wall, but this wall is so skinny, it's going to be too weak and flexible to be any good to resist earthquake forces. So we can really neglect it. And the same with this wall. And like this wall is so short. And notice if we go to the it's on grid D in the middle of the plan. If we go to lantai 2, there's no wall there. And so it's not useful to resist earthquake forces. There's no structure here. So going back to lantai 1, the floor plan. So we don't have resistance along here. What about grid E? Well, yes, in grid E, we have a wall here and a wall here. And do they go up to the roof? Let's check. Well, yes, this wall goes up to the roof, although it does have an opening, a door, which will weaken it. But this wall here is very good because it has no penetrations and it goes right up to the roof. So we do have some resistance on line E from these two, which they could be confined masonry walls. So that's good. We've got some resistance at last. And then we go to grid line G. And here we have excellent resistance in the X direction because this wall is solid right across. But we do have a problem because we've got this penetration here. This is a penetration. And so the earthquake forces, they can't get into the wall on this over this length here. They're forced to get into the wall just at each end, here and here. And so that makes this wall not quite so effective. Like, let's look at section B. Let's look at this point here in section B. See, here's the gap. here's the gap between the floor diaphragm and this is like the confined masonry wall. Now, the other problem is that this wall, it really needs to go up to this level so that we can have a tie beams tying the building together to create like a diaphragm at this level. So the earthquake forces can move sideways through bond beams or tie beams and then go down the vertical walls. So at each level in a building, we must have a sort of a diaphragm to tie the building together at that level. Like at Lante Dua, the floor slab ties everything together very nicely. You know, it acts as a really strong diaphragm. But at this roof level here, we need a series of tie beams to create like ring beams. Is it a ring ballock that will tie and stop the building shaking apart at the roof level. So those are the improvements that we would need to make to this design. So going back to the ground floor plan again. So what we've got now is that we've got some resistance on grid G, some resistance on grid E, but no resistance down here. And so this means the building has got a severe torsion problem. Like during an earthquake, the earthquake forces will attack at the center of gravity of the plan, like about here. But the resistance from these two grid lines will be about on this point here. And so there will be this torsional eccentricity. And so the building will twist. It'll have huge twisting due to torsion. And so there'll be very severe damage, probably collapse at this end of the building. You know, it will collapse. So that is the problem that I see with this building in terms of resisting earthquake. And so I'm going to pause and see if you have got any questions, and then I'm going to give you some solutions that the student could use to improve the design.
Bapak Ibu silakan jika ada yang ingin bertanya atau menanggapi.
Prof. Andrew, I would like to ask a question. This is the result of design studio in third semester. Should we evaluate the result of the design study in the next structural subject mata kuliah struktur in the next semester, or do you have any suggestion to evaluate the design result?
Yeah, that's a really good question. I think when a student is at semester 3, they don't understand about earthquake resistance. And so my suggestion is that maybe in semester 4 or 5, the students have to go. So in semesters 4 or 5, after the students understand about earthquake resistant design, the student is asked to go back to this design and to identify the earthquake problems with it and to suggest improvements.
Thank you, Prof.
We've been doing that at Victoria University and it's been very successful. We ask a student to revisit one of their previous designs where they weren't expected to have earthquake knowledge and to report on the weaknesses of the building for earthquake and to suggest improvements to strengthen the building so they would make changes to their design to bring the building up so that it would be safe in earthquakes.
Thank you, Prof. Andrew.
Any other questions or comments? I mean, maybe some of you disagree with me. So please tell me if you have a disagreement with my analysis.
Apakah
Okay.
ada tanggapan?
Let me continue.
Iya.
Before I suggest ways to improve this building, I just want to highlight one thing to you. I want to show you this wall here. See this wall here? It is 2 stories high and it is not connected to the main structure. So if we go to lantai 2 here, you can see that piece of wall. It is 3 meters long in plan and it is about 8 meters high. And so that is actually very dangerous. That wall will just flap in an earthquake and collapse. And so we need a little tie beam to tie the wall back here into the floor diaphragm at each level. So here we need a little tie beam, and also up here there needs to be tie beams at this level, which is what I was discussing earlier. Right, well, if we want to make this building safe in earthquakes, we've got to provide more resistance in the X direction. Now, because of the program of the building, if we look at, you can see that the student has got a lot of glazing, a lot of windows at the front of the building. And so clearly it's not possible for us to use solid walls to resist earthquake near the front of the building. In order to maintain the natural light entering the front of the building, we're forced into using moment frames to resist earthquake. And so what I suggest is that going back to the floor plan, that we put in, say, a moment frame, a couple of 1 or 2 moment frames at the front of the building and even at the back of the building. And that means that the these walls here would just be infill walls. And we wouldn't be relying on confined masonry at all. So that is my suggestion. So what I want to do is to stop sharing my screen, and I want to share another screen with you here. Can you see this new screen?
Not yet. Oh, yes.
And so what I've done is I've gone to the Resist software and I've modeled this little house in Resist. And in the Y direction, I've modeled the two walls, which are in confined masonry. My software doesn't model confined masonry, but I've modeled the walls as reinforced masonry. And then in the X direction, you can see I've designed 4 reinforced concrete moment frames. And the purpose of these moment frames is to resist the earthquake in the X direction. And like, this is what a moment frame looks like, you know, in a very tall multi-story building. And so in this house, I've got like this moment frame has got a column, beams at each level, and two bays. So there's like 5 meter span for each of the beams. And here we have the rigid joints that we need in moment frames. And so if I go to resist, I just need to look at the results. And so in my resist model, this is for the X direction and the concrete frames. They are well beneath, well, the 100%. So they will comply with the Indonesian code as being strong enough. But it's important to note that the depth of the columns is 40 centimeters. And so the columns have to be this dimension. They have to be 40 centimeters long, and the width of the columns has to be about 24 centimeters wide. And the beams, they have to be about 40 centimeters deep and 20 centimeters wide. So those are the dimensions of the frames that would be needed in this house if we had 4 frames. If we wanted to, we could just have 2 frames, say one at each end of the building. So if I delete that frame and delete this frame and look at our model, see now we've just got a frame at the front and a frame at the back. That's all we need. If I look at the results, you can see that I've got some red failure of my frame. So I've got to go back and I've got to increase the size of my members there. So if I make my columns and beams 45 centimeters deep, then that house will comply with the Indonesian loadings code. You know, it'll be strong enough. But the student has to realize that, you know, these columns are a lot bigger, aren't they? And the columns have to be orientated correctly. So, you know, the column has to be 45 centimeters long here. And here it's got to be 45 centimeters long. Here, 45. And then the columns can be 25 centimeters thick. And so this is the structure that is needed to make this building safe in earthquakes. It needs a couple of good, strong moment frames. And then it will be fine for earthquake. Let me just show you one other thing. When we look at the results, this is the results of the two long walls. And this flashing light, if I click on it, it tells me that given the height of the wall, remember, that the story height of this house is 4 meters. So it's a very tall house. And to stop the walls from buckling during earthquake, the walls have to be at least 23 centimeters thick at the ends of the wall, because the current thickness of, say, 15 centimeters is too thin. So what would happen is that during an earthquake, the wall would just sort of buckle like this piece of paper does. You know, it's just not thick enough to act as a shear wall. And so that can be solved quite easily by just using the columns of the moment frames. You know, they are deep enough at each end of the wall to stop the walls from buckling during an earthquake. So this would be my suggestion to the student to, you know, improve the design. So if I stop sharing and go back to the original PowerPoint thing, so what I'm saying is that in the final design, oh no, sorry, it's on grid line A. So the student has to insert three columns like that. And here is the beam of the moment resisting frame going between the columns. Excuse my terrible drawing. And here there will be another column of the frame. This is the 40 by 25 column. And here there will need to be another column. And then if we've got 4 frames, here is another frame here. The column has to go somewhere here. And the other column, well, maybe it goes here. But but see how the columns have to be strong in the X direction. You cannot have a column like that against earthquakes in the X direction. This column is almost useless. So the student would have to do some small replanning of the spaces to accommodate this structure. But, you know, to me, it would be quite feasible. I mean, I suppose you can see that it's better just to have two frames, a moment frame here and a moment frame, say, on this grid G. And then it's reasonably easy to accommodate, you know, a total of 6 large columns. So that's my suggested solution that the student could use to bring this house up to, you know, a standard where the house would be safe in earthquakes. So I'm going to pause and invite any questions and comments, please.
Pak Krisna, silakan. Tadi sepertinya ingin bertanya.
Okay. Good afternoon, Prof. Andrew.
Hello.
Hello. Okay. I will ask something, but it's back to the first topic about teach structure to architecture students. Okay. As you said before, yeah, we should giving the students a basic principle and some problems to be solved. Okay. But the basic principle, which part we should start to teach them. I mean, this year is my third period. Teach the student about basic analytical structure. Okay, and this year I teach them start from structural principle, and then about the load, living life load, and then I taught them about the upper structure and substructure. Okay, so actually it's a change for my method of to teach them, because the last year I start with substructure and upper structure. So this year I changed that. I start with the principle, but I don't. I need suggestion which part we should we start about the structural requirements and then the load, or structural requirement, and then we can lanjutkan. We can continue with substructure or upper structure. Okay, I think this is my question. Okay, thank you.
Well, thank you for your question. It's rather difficult for me to answer it because, like, I believe you can't really separate out like lower structure and upper structure, because like if you take, for example, a frame has to work throughout the height of the whole building. Like here's a frame to resist earthquake forces. And so the frame, you know, has to rise the whole height of the building in a continuous manner, and has to consist of beams and columns and rigid joints. And I mean, even a shear wall, you know, it has to rise from the foundations There has to be a strong foundation for a shear wall, and then the shear wall rises up to possibly take gravity loads and lateral loads. So, I mean, I think it's better to talk about the systems the students use. Like, you know, I've talked a lot about confined masonry. And I mean, I think we use confined masonry for up to 4-story buildings. And so the students need to understand the different possibilities of structural systems, like this confined masonry, this post and beam. There are concrete shear walls. There are moment frames. There is cross bracing. And so the students need to have like the structural vocabulary of the possible structural systems that they can then use in their design projects. But I mean, there are many different ways that you can introduce this material. And I'm not sure exactly how you are doing it, but that might be okay. I mean, there's no approach is perfect. And so I think we just, each of us have to keep an open mind and just see if we can keep on improving the way we are teaching. So, I mean, you are teaching one way, you need to reflect and see if maybe you can improve that approach. And if you can, well, then you make changes. If you feel your approach is the best one that you're aware of, well, then, you know, you just stay with your approach. So yeah, there's no one way that is perfect. I mean, I've told you my approach is to teach the different systems, because each system can be applied to buildings of different heights. Like, take a moment frame, you know, you can use that in a 1-story building if you want to, but you can also use it in a 10-story building. It's just that the members become a lot larger. Take a shear wall. A confined masonry shear wall is used in 1-story houses in Indonesia, but it can also be used in 4-story buildings. And so it's about, in my opinion, it's very helpful to give the students a range of structural systems, and they can choose which ones to use. So I apologize. I don't think my answer is a very good one, but it's probably the best I can do tonight.
Okay, thank you for the answer.
You're welcome.
Pak Andrew,
Questions, please.
Pak Andrew, I would like to ask a question.
Yep.
Let me maybe draw on the screen. So you mentioned before that this column is not really effective for the earthquake on this direction.
Absolutely.
Yes, because of the shape. Do you suggest what about the earthquake on this direction? Do you suggest to change the shape into square one? And maybe the second question, I see that there is a trend of students, they like to hide the column, but sometimes we need a bigger column to support the structure. How would you respond to that?
Yeah, look, they're lovely questions, Ibu Seshi. Well, first of all, if we are designing a building where we are resisting the earthquake forces with moment frames in both directions, X and Y, then yes, we would probably choose square columns. So your thinking is absolutely right. But for this house here, you see in the Y direction, we've got all these two strong walls. So we don't want to waste money and build a moment frame in the Y direction, because we've got so much strength anyway with all that confined masonry wall. So we don't want to waste money. So there's no need to have these frames in this wall, because the wall will do the bracing itself if it's built as a confined masonry wall. And so therefore, it's a lot more economical just to have these columns like this in the X direction, rectangular, because we only need their strength in the X direction. Now, onto your second question. I mean, you're absolutely correct. I mean, architects, where possible, prefer to hide the structure so that it doesn't disrupt wall surfaces, etc. But the reality is, especially in a higher building, the columns will always be a lot larger than the thicknesses of the walls. And so the columns will always be visible because they will be wider than the walls. And so the students have to realize that, and they've got to draw, like if say this was a 4-story building, well, I mean, they've just got to draw the columns the right size and then accept them and do their planning accordingly. Because we can't reduce the size of the columns, otherwise the building will collapse. It'll be too weak.
Yes.
So we have to be led by the engineer's sizing of the structure. And then we have to, we've got to sort of compromise some of our architectural pure ideas so that we can integrate the structure with our architecture. So I'm afraid that's all I can really say. Would you like to sort of carry on this discussion a little bit?
Well, I think I already understand, and that's all from me.
Okay. Are there any other questions, please? So just in summary, this house was a pretty good attempt by the student in semester 3. You know, I mean, being honest, I think the student has done a pretty good job considering everything that the lecturers have asked of the student. But the student has made lots of mistakes, some in the drawing, a lot of beams are missing. But in terms of earthquake, the building has got plenty of strength in one direction, but it hasn't got sufficient strength in the other direction. And, you know, for a semester 3 student, we can't expect much better than that, I don't think. And so maybe the idea is to ask the students to revisit their schemes after the students have been given some basic principles of earthquake resistant design. And I mean, ideally, you would get the students to use, some software like Resist so that they can do their own design themselves, to work out what the size of the members can be. But if you don't ask them to use Resist, you've got to give them some guidelines to make sure that the structure that they're putting in their design is sort of reasonable, and it's not ridiculously weak. I mean, Francis Ching, in his book, Building Construction Illustrated, gives some rules of thumb, doesn't he, about how big the columns have to be and so on. So, I mean, at the very least, your students must use those rules of thumb. But in the best case scenario, they would use software like this to help them to design their building. And as you know, the software is free and is readily available. So I think, like, I've talked extensively about this first student project. And I think we've probably had enough. I mean, there were 3 other student projects that I could discuss with you. And I've got the plans, actually, of the second one. But look, I personally think that this is the project, the second project. But Ibusushi, maybe it's time to draw this workshop to a conclusion. And in the next workshop, we could look at other student projects.
Yes.
Up to the participants to decide, what they think is the most valuable thing to do.
Yes, I agree. Bapak Ibu, mungkin ada yang ingin ditambahkan before we close? Is there anyone to maybe give suggestion or response? Because we've already discussed for 2 hours, and I think we had a lot today.
Yeah, we don't want to overdo it.
And I agree with Prof. Andrew. If maybe next time we also could discuss about other type of building, because this drawing is from the third studio. All of them designed for 2-floor houses, and for the fifth studio they designed for the 20 floor. 20 floor, is that correct? So maybe it will be more complex if we talk about the earthquake and seismic.
Exactly, that's a great idea, Ibusushi, and maybe also we could look at 1 or 2 long span designs.
Yes, sure. Bapak Ibu, if there is no other response, I would like to say thank you for everyone that already participate in this discussion, and also thank you for Pak Arsyad, Pak Harida, who already present, and also of course Pak Andrew, who already for this the fifth discussion always give us a lot of knowledge in term of teaching structure for the architecture students. Thank you so much.
You're very welcome. It's been a pleasure to be part of this workshop. And I just invite you for the next workshop to think of any questions that you would like us to discuss. And so please send any questions. It might be an interesting student project that you would like to get my opinion about. Please send this material to Ibu Yulia or Ibu Sushi, and we can arrange that for our next workshop. So
Sure.
thank you all very much for your attention, and I just give you my very best wishes and look forward to our next workshop.
Sure. Thank you so much, Bapak Ibu. I think I should close today with thank you again. And Bu Yulia, if you want to add to say something before we close.
No, I just want to say thank you very much, Prof. Andrew, for your willingness to stay with us in this fourth discussion session. I think we will meet again in August, maybe. Yes. Thank you very much, Prof. Andrew.
Okay. Goodbye, everybody. Selamat siang.
Selamat siang,
Selamat
Prof.
malam,
Good
Pak
night,
Andrew.
Prof.
Good night for you.
Betul,
you.
betul.
Take picture, take picture.
Bye.
Bye-bye.